And welcome back. We are back from a quick afternoon lunch break.
It's been good.
And I think we were chatting now during lunch, and it's been an absolute morning of just headlines.
Good news. Yeah?
From a local manufacturer stepping into the void to wanting to a young entrepreneur looking to launch the South Africa's first locally manufactured EV. Mr. Mazibuko from Mazibuko Motors and his M1B, which is really exciting.
I like the code as well.
Like it.
I like the name. Yeah.
Very good. And then we sit down with one of the main OEMs in the country, BMW, and we hear from Clayshire Johnson exactly what BMW is planning. And excitingly, confirming a few models coming to the country in the next 12 months.
Yes.
And then on top of all of that, we listen to a man who, by all accounts, everyone tells us, is the preeminent kind of authority that the policymakers are talking to. And everyone said, policy, policy, policy. We need to fix our policy. We need to get policy up to date. And he drops the bombshell at the end of his session that we can expect fundamental policy changes within the next 6 to 12 months. Yeah. That's a game changer, Devon.
Total game changer. It feels like this is top gear, and on this bombshell, because we've had plenty bombshells this morning, and the future is looking even brighter.
Fantastic.
Great stuff.
So what has been very nice in this morning is we've had lots of interaction with our viewers. Mm-hmm. So we're back live on Facebook and YouTube. Our Zoom attendees are all signing in after their lunch breaks. And we'd like to encourage you, if you're on Zoom, please send a Q&A on the questions. We'll try as much as we can to get to them. And if you're watching us through YouTube or Facebook, please kindly comment on those feeds and our team will monitor those comments and feed them through to us. And again, we'll try as best we can to get your comments and your questions to our speakers and let's get those burning questions answered. Absolutely. What's been quite nice is that our speakers are really well prepared and they're giving us a lot of info. So a lot of the questions are getting answered in the sessions.
Yes. First quality speakers, first quality topics.
100%.
And, I think a great start to EMCSA. And I really hope it doesn't stop. So we keep the coffee chats going as we build up to next year, EMCSA.
100%. So this afternoon, we have a gentleman who's joining us again from Australia. It's quite late where he is. So from our side, it's a real privilege that he stayed up so late. It's 11 o'clock at night where he is. So he's up late for us, fueled by hopefully a bit of caffeine and some coffee. Mr. Robert Kochhan, and he is the senior professional in the Sustainability and Resilience Australian Road Research Board, the ARRB. And Robert is here to talk to us about environmental impact of low and zero emission vehicles. And I think, Devon, this is a great topic because I think everyone says, I've got to go drive a green vehicle, green. And the naysayers will say, but it's not that green. You're still doing this, you're still doing that. Mm-hmm. And we need to understand that argument so that we can provide facts. And I think like Gaylord did, is say, but look at the whole picture. And I'm hoping that Robert will give us that whole picture scenario. And I'm looking forward to see what he says from the research that he's conducted in Australia and how we can learn from that in a South African perspective.
Absolutely. This is early days. I mean, this EV language is quite new. We all are learning from a vehicle perspective, from a production perspective, and therefore we can always look to our friends overseas to please guide us.
Yeah.
So looking forward to hear what Robert has to say.
So Robert, I believe you're online and with us. Welcome, sir. How are you?
Oh, hello. I'm very good. Thank you. Thank you for the introduction. Hope you can hear me all well.
Yeah, we got you loud and clear, sir. So I think you've got a really interesting topic, and I'm going to allow myself and Devon to kind of step back a little bit and for you to take us through what is the environmental impact of low and zero emission vehicles. I think a little bit of a different side of the argument and help us understand this side of what we've been talking about. So over to you, sir.
Yeah, thank you very much. So I think that's a very important topic in general because it explains a little bit why we are doing all of this, the transition to electric vehicles. I mean, it's nice technology, but there's a certain purpose behind it, and it certainly can help to lower to achieve our climate goals and lower the overall impact of road transport in general. So I'm talking a little bit about that from an international perspective, and then maybe some slides on Australia and South Africa as well, of course. So the agenda is a little bit of a background. about that topic, and then the different or the main stages of the life cycle of a vehicle, which is the manufacturing stage, the use phase, and the end of life phase. And then after the break, or in the later part of the presentation, I'll talk a little bit about what the Australian Road Research Board is doing in terms of electric vehicle research in general, and what I've been doing in the sustainability and resilience team within ARRB. As I mentioned, life cycle. Yeah, when we talk about electric vehicles, we have to take into consideration different things such as costs, air pollution, and of course the emissions. Emissions is what I want to talk about in this presentation, but there's also quite a few other things. When we talk about electric vehicles, what I've been involved in personally, in terms of research on the costs and the air pollution side, and on other things such as the noise of electric vehicles, the saving fossil fuels for other applications rather than burning them in our cars. But this presentation is about the emissions, which is certainly an important aspect. And a little bit of a background, these slides show Australian data, but maybe a little bit different or in other countries. If you look at road network from the 1970s until today in Australia, there's a growth of 200% of our road network. And most of these roads are sealed roads, freeways, which means if there are more roads, there are more cars as well. And that's actually shown on the next slide here, where we can see the growth of the vehicles that are operating on the roads. Also, since the 1970s, it has grown by about 250%, from about 4 million cars to more than 14 or 50 million cars, which is quite a remarkable growth. And if we keep going on like that with population growth and the vehicles on the road, there are more and more emissions over time. And electric vehicles can certainly help to bring down that curve in terms of emissions. This is another slide, again, with some data from Australia. It might look a little bit different in other countries, where we can see the brown column here in the middle, which represents the transport emissions of as a share of the total emissions of the entirety of Australia. 18.3%, almost 20% of the emissions come from the transport sector. And a third of the emissions comes from electricity generation. And if you highlight those emissions, we can see that most of the emissions from the transport sector are actually road transport sector. It's not the trains, not the ships, and not the airplanes. It's road transport. So there's a massive potential to reduce emissions if we introduce cleaner electric cars, or cleaner cars in general, cleaner modes of transportation on our roads. And if you look at the electricity, if we can reduce that as well, that's certainly a very important point to consider when we talk about electric cars. We can't keep using the electricity that we generate today. That is generated in some countries more, in some countries less, by fossil fuels. So we need to transition to more renewable energies as well, at the same time as we transition to electric vehicles. Here's another slide, or another graphic about visualizing the background, what's happening at the moment. And this is the uptake of electric vehicles worldwide, different regions of the world. But the most important thing that we can see here is that there's an exponential growth, and it's continuing to trend upwards, which means the electric vehicle market is gaining momentum. And certainly interesting to look at the life cycle emissions and what impact that can have in the future. Then I want to talk about the different phases that I was talking about before: the manufacturing, the use phase, and the end of life of the vehicle. So this is a very brief overview, a very high-level overview, but it gives you a bit of an insight of what I'm talking about here. In general, if you talk about the manufacturing emissions, an electric vehicle is not so much different compared to a normal vehicle, except for the drivetrain, the electric drivetrain, compared to the diesel or petrol drivetrain. And in particular, we need to look at the battery, at the emissions from the battery manufacturing, from battery production, which is the majority of the difference when it comes to considering the emissions from from battery electric vehicle compared to a petrol diesel vehicle. And in the past, the emissions from battery manufacturing have been estimated, but they are the studies we found are a little bit outdated. They use data from low volume manufacturing and also data from that uses average electricity mixes, which are going to become more renewable in the future. So overall, the estimated battery emissions that are estimated in many studies today are a little bit too high. They're going to come down in the future. That's something we need to consider, although overall, the emissions from manufacturing a battery electric vehicle will be higher than the one for a petrol vehicle, mainly because there's a lot of energy that goes into the extraction and production of the raw materials that are used in the battery, the cathode materials, for example, or the mining, refining of materials and metals. So there's still a bit of a disadvantage for the electric vehicles in terms of emissions, life cycle emissions. At the beginning of the life cycle of that vehicle during the manufacturing stage, but that can be offset during the use phase. I'll talk about that a little bit later. The picture below, by the way, is one of the gigafactories of Tesla in the United States, with a lot of solar panels on the roof. That highlights already that battery manufacturing may be cleaner than we think it is today because of all the renewable energy that is used in this particular case. Going on to the next slide, we see two different graphs here showing what impact the carbon intensity of the battery manufacturing has on the overall life cycle emissions of a car. On the left-hand side, we see a graph where on the y-axis we can see the savings potential in terms of percent, and on the x-axis we have the carbon intensity of the electricity generation. And of course, the more fossil fuels are used to generate that electricity that is then used to produce the battery, the less savings potential there is. And if you get to a point where we have 600-700 grams CO2 emissions per kilowatt hour of electricity that is used to produce the battery system, then the life cycle emissions advantage of a battery electric car will be minimal. Whereas if we use fairly clean energy, there's a big savings potential in terms of life cycle emissions, 60 to 80% over here. And on the right-hand side, that's a little bit of a similar graph. But depending on the mileage of a vehicle, at the beginning of the life cycle of a vehicle, that battery electric vehicle has a disadvantage. It's negative 60, 80% more emissions. But over time, as we fuel or we charge the electric car with clean energy, it becomes it becomes better in terms of emissions compared to a petrol diesel car. And depending on the battery size that we have, there's different lines in that graph. But that highlights that at the beginning of the life cycle, a battery electric vehicle will be more emission intensive, but over time it will gain advantage compared to a petrol vehicle or diesel vehicle. Then if we look at the use phase, that's the second phase, and that's probably the most important phase because it creates the majority of emissions of the life cycle emissions of the vehicle. And I've put two terms over here, the well to tank emissions and the tank to wheel emissions, which both have to be considered when we look at the electric vehicles, or not only electric, but also the internal combustion engine vehicles. The well to tank emissions are the emissions that are created for the manufacturing of petrol or diesel and distribution to the petrol stations, or for the generation of the electricity that we charge our cars. And the tank to wheel emissions are actually emissions from burning that fuel. And in the car, in a internal combustion engine vehicle, and there are no tank to wheel emissions for the purely battery electric vehicle because it's emission-free, locally emission-free. But we have to take into consideration both of them in order to get a full perspective of the emissions during the use phase. And we also ideally should take into consideration the future carbon intensity of electricity because that's constantly evolving. When we do a study, we can't just use today's electricity mix, but we have to take into consideration that most likely the electricity mix in the future is going to be less carbon intensive. There will be more renewable energies in in the electricity mix that we use to charge our cars, and that creates an extra advantage for the battery electric vehicles. I've put a few graphs here for especially South Africa and Australia in terms of electricity generation, because that's, as I mentioned, a very important part. And as we can see, those two countries are fairly low in the renewable energy shares of the electricity mix. This is data from the International Energy Agency, so it's fairly reliable. And other countries, of course, have, as you can see on this on the right side here in the right graph, the EU, USA, China, UK, they all are well below what Australia and South Africa are at in terms of carbon-intensive energy generation. And the question is whether in Australia or in South Africa we can still achieve an advantage of using electric vehicles compared to petrol diesel vehicles if the energy that the electricity that we use to charge our cars is that carbon intensive. And I've done some calculations about that, which I've put onto this slide here. This is a bit of a graph where we have the use phase emissions in kilograms CO2 equivalent per 100 kilometers on the x-axis, and we have two y-axes, one on the right-hand side for the liters per 100 kilometers of petrol diesel. That's for the gray graphs, gray dotted lines. And on the left-hand side, we have the kilowatt hours per 100 kilometers for the electric car, for the battery electric car, for the different regions that are presented in the slide before, Australia, South Africa, and some of the other regions worldwide. And the cleaner the energy mix is, the further left the graph is on this particular figure. On the far left here, we have Norway, which has almost 100% renewable energy from hydro, and South Africa and Australia are somewhere in the middle here. And if you look at, or if you can compare a vehicle, for example, one vehicle that uses about 8 liters, 100 kilometers of petrol diesel, then we are ending up about maybe 200, 250 kilograms CO2 equivalent per 100 kilometers. If you compare that to a car which uses 20 kilowatt hours per 100 kilometers, all of these regions, and even Australia and South Africa, they can achieve a savings in terms of emissions from the use phase. Of course, in Australia and South Africa, not as much, a bit more where the energy mix is a bit cleaner, but still in those countries we can achieve something. And I think this highlights pretty well that there's a certain potential there. The cleaner the energy gets, the better it is. But even at the current stage, some savings are possible. And if we extrapolate that towards some higher level of emissions, I've scaled up the values that I've calculated previously in the previous slide and put it onto the graph here, which shows the percent of the world road vehicles emissions that can be saved if we consider, for example, a replacement of our petrol and diesel cars, 5% replaced by battery electric vehicles, 10%, 20%, 50%. If we replace all of our current petrol and diesel cars, we have a potential to save 25% of all world road vehicle emissions at this stage, and that represents about 1.4 billion tons of CO2 emissions per year. So this is the use phase. There are certainly some savings potentials out there, which we should be looking at. And then finally, of course, there's the end of life stage of the vehicle, and that's in particular the battery. Most vehicles are, or the components of most vehicles are recycled. There's all the plastics, the rubber, the metals. That is not so much different from a battery vehicle compared to an internal combustion engine vehicle. But when we look at the battery, there's some new technology and some materials in there which are not in a normal petrol vehicle, and that needs to be looked at in terms of recycling or in terms of second use phase of such a battery. And if we look at the recycling, we are not only should take into consideration the recycling itself, which is shown on the bottom left of this graph, where we have the material recovery and the smelting of the battery materials, to be able to reuse the material in a new cycle of battery production. But we also should take into consideration the process of collecting those batteries, the supply chain process, which adds even more emissions to the overall cycle in terms of collecting those batteries, transporting them to recycling facilities, and so on. That's a part that can also be optimized. And then finally, I want to show this graph here, which shows a little bit the different technologies that are possible to recycle those batteries. And on the left side here, we can see the percentage of emissions compared to lithium-ion battery production, which is the 100% line here, compared to recycling a battery. So if we were to produce a new lithium-ion battery from virgin materials, we would be at that gray line. If we recycle the battery, we would be, with different technologies, we would look at the blue and green bars here. If we look at the greenhouse gas emissions, for example, both of these technologies have some savings. So it makes certainly sense to recycle batteries if we optimize it in a certain way in order to reuse those materials in new battery production compared to just using virgin materials. However, there's a problem, and the problem is that at the moment, and this is shown in these graphs here, at the moment, the number of batteries that is available for recycling is very low, because the number of electric vehicles on our roads is very low, and they are also fairly new vehicles, so they haven't reached their end of life yet. So the available gigawatt hours of battery capacity that is available for recycling is far lower than the actual demand for the new batteries. So there's still a need to produce virgin batteries from virgin materials. Okay, so this is a very quick overview of what we should be looking at in terms of the different life cycle stages. And then if we get to a summary, summing up all the different life cycle stages, including manufacturing, use phase, and end-of-life phase, we can come up with a graph like that. That's also a graph from the International Energy Agency, which compares average passenger vehicles on an average global scale with an average carbon intensity of electricity generation against each other. On the left side, we have the battery electric vehicles with different battery capacities, a small battery and a bigger battery. And then on the right-hand side, we have the hybrid vehicles, fuel cell vehicles, and in the middle, the internal combustion engine vehicle. And on average, there's certainly some savings potential of the battery electric vehicle compared to the internal combustion engine vehicle. But if you look at the hybrid vehicles, they're also fairly well established. However, in terms of emissions, they're on a similar scale compared to the battery electric vehicle. However, the battery electric vehicle has a certain advantage where we should consider the future of our electricity generation, and if we manage to use cleaner energy in the future, that life cycle emissions of the battery electric vehicle will improve far, and will be much better than for the internal combustion engine vehicle, for example, and also compared to the hybrid ones. And finally, if we scale this up again, so if we look at the total life cycle emissions that I have got in this graph here, if you scale it up on a global scale and look at the global annual emissions, again, replacing our internal combustion engine vehicle by battery electric vehicle, you can achieve about 2.5% of emissions can be reduced from a global scale. That is about 1 billion tons a year in terms of life cycle emissions. Well, that was a very quick overview of everything. I hope that's sort of understandable. And I'm happy to answer some questions right now
Awesome.
or after the break, and then I will go into what ARRB has been doing in terms of their projects a little bit in that space.
Well, I think Robert, it's very sure a lot of information, and a lot to digest. I think I've got one question straight away, which is, if we look at the share of the vehicle life cycle emissions, what percentage of these are from manufacturing emissions?
The life cycle emissions. If you go back to this slide here, we look at the bottom of the graphs, for example, here. If you look at the light blue and the dark blue share, you can see the bottom part here, which is the manufacturing emissions, and all the top part are basically the use phase emissions. So if you compare the bottom blue part to the overall height of the graph, that's maybe about 25% of the overall emissions, and that's on a global scale. Of course, it depends very much on how much energy, how clean the energy is that you use to fuel your car or to charge your car. If you, for example, have a house and the house has solar panels on the roof, and you always charge your car at home, then the use phase emissions will be very, very low, and the share of the manufacturing emissions compared to the overall life cycle emissions will be much higher than 25%.
Okay. Look, it's interesting to look at the whole life cycle of a vehicle, not just look at it on the part of the road, and understand the full life cycle of it. Devon?
Yeah, I've got a very interesting question. Robert, nice to meet you. What is the share of road transport greenhouse gas emissions in other countries other than Australia?
But to be honest, I don't have a figure about that. I know that in Australia it's about, as I showed, 18%. However, I have looked it up as part of my research. There is, on the global scale, it's roughly 11.5 to 12%. That's a global average. Of course, it probably depends very much on the country, whether there's a lot of road-based transport or if there's a lot of rail transport or other forms of transport. I can't really answer the question fully, but on a global scale, it's about 11 to 12% of all emissions come from road transport.
Okay, and I've got one more from one of our audience members who said he's asked you, what is the potential reduction? And maybe this is something that I don't know if you'll be able to comment on. It's talking about global warming. Is there a potential? What is the potential reduction in temperature, global warming, due to a reduction in emissions or a ratio basis? Is there something that we can look at towards how we can reduce global warming through these reductions?
Well, the general intent of doing this, or why we should be looking at it, is of course that the contribution of the electric vehicles to meeting climate goals and eventually slowing down climate change. But I can't really say how much you can save through battery or battery electric vehicles in terms of how much % of that goal can be achieved through that. That's I think hard to tell, and I'm not sure if anyone can.
Sure.
And can come up with a specific figure.
Sure, fantastic. Well, look, I'm looking forward to kind of the rest of your presentation. And let's see what more you can share with us.
Sure, no problems at all.
Fantastic.
Okay, so we go straight on to the second part without a short break. That's fine. So if we go on to what I've been working on, what the Australian Road Research Board has been working on. Of course, we are based in Australia, and I want to share a few of the insights from Australia in terms of what we have been doing in the electric vehicle space. Unfortunately, and that's a little bit similar probably to what is happening in South Africa at the moment, compared to other countries, other regions in the world, especially Europe, China, United States. We are far behind those regions in terms of electric vehicle uptake. And that's also due to the lack of policy support in Australia for electric vehicles. On this slide here, I have put an overview of what Australia has been doing or has been achieving. in terms of overarching policies, consumer policies, industry policies, and for the different states or different regions in Australia. And we can see that a few boxes are ticked here, but not very many overall. Some states are further, or some regions in Australia are further ahead compared to others, are more supportive of electric vehicles, have put up more schemes, more support measures overall, but other states are a little bit further behind. But if we would be looking at this kind of overview for other states or other countries, other regions in the world, it would be looking much better. So there are very limited financial incentives, for example, in Australia. So this is something that we at the Australian Road Research Board are looking at. We can advise companies or agencies what they should be looking at, what should be doing to support electric vehicle uptake, also based on international experience and learnings, what we can, for example, apply here in Australia. And this is another overview for the different states in terms of readiness for electric vehicles. For example, the Australian Capital Territory, which is Canberra in Australia, is probably the most electric vehicle ready. They have a lot of government fleets, government electric vehicles that are being used. But in the other regions of Australia, it's fairly low. And I'm working at ARRB to look into this sort of thing and to try to find out what we should be doing by looking at other regions worldwide as well. And then I want to share some of the projects that we've been doing here that are potentially interesting for everyone to look at in terms of electric vehicles or related policies and measures that we have been looking at. The first project is the Pavement Lifecycle Sustainability Assessment Tool, which I'm going into a little bit more detail after that. Then, of course, we have low and zero emission vehicle policy that I was just talking about before. Decarbonization of the heavy vehicle sector here in the middle. We've been advising one of the agencies in Australia what they should be looking at in terms of bringing down their emissions from the heavy vehicle sector, from the mining sector, from the road transport, trucks, for example. Then we have been looking at standardizing signage for low and zero emission vehicles, because there's a real issue in Australia that is developing with the uptake of electric vehicles, where every region in Australia tries to a little bit do their own thing, come up with different symbols for electric vehicles to put on their road signage. And we are looking at standardizing that, or proposing standardized signage or symbols. Then we have had another project about the road operators action, what road agencies should be doing to support electric vehicles. We are also looking at other technologies such as positive energy roads, which is not electric vehicles in itself, but it's sort of related to it, because as I was mentioning before, it is important to look at low carbon intensive means to generate our electricity, and positive energy roads are one technology as well. We can generate renewable energy within the road corridors. And of course, the life cycle assessment of electric vehicles that I was just talking about in the first part of this presentation. I want to go a little bit into the Pavement Life Cycle Assessment Tool. Essentially, that's a model that we have been building up in order to assess the life cycle emissions of a pavement, not of the electric vehicle only, but also of constructing the pavement, maintaining the pavement, and then decommissioning it or repairing it over the cycle, and of course running cars on that pavement. And this tool allows to compare different pavements, different pavement topologies, also with the integration of alternative materials, where we can recycle materials, for example, crushed glass or chrome rubber from tires, which we can put into pavement, and in order to lower the overall emissions impact of that pavement. But a very important finding from this tool was, or from this work, was that the vast majority of all emissions of a pavement are not generated by the pavement itself and the construction and maintaining it, but it's are the emissions from the vehicles that run on that pavement, that use that pavement over its life cycle of 10, 20, 30 years. And that depending on where that road is, where the pavement is located, it depends a bit how much of the emissions come from road transport, but mostly it's in the range of 80 to 90%, especially if we look at urban roads, not so much as country roads, of course. And that that's one of the findings that highlighted to us that it's very important to look at the use phase of a pavement, so the cars itself, and how we can reduce the emissions from that use phase of the pavement. And that, of course, includes looking more at the electric vehicle space for our road transport. So that's one of the bigger projects we have been working on and still working on at the moment. And one of the other projects here on the left is the decarbonization of the heavy vehicle sector. As I mentioned, it's one of the projects we've been doing for one of the agencies in Australia, state agencies, road agencies, and we've been collecting different opportunities for them to lower the impact of heavy vehicle road transport, including mining and agriculture. And on the left here, I've just put a few examples that we found that we suggested to them. One of them is, for example, the electric waste trucks. They have been running in Australia in different parts already, and it certainly makes sense to use such a truck compared to a diesel truck, because it's mainly used in low speed applications, stop and go traffic, where the trucks collects the bins, the curbside bins. And in that particular application, an electric vehicle or electric motor is much more efficient compared to a diesel engine, which saves or can save a lot of emissions. And of course, there's less noise involved as well. Electric motor is much quieter than a diesel truck going through the suburbs. Another technology is shown on the top left here, or the middle left, the truck that collects energy from overhead wires. Similar to a train, that is a project running in Germany that could potentially be implemented in order to reduce emissions by having trucks run on a freeway, collecting energy from the top, and then they can recharge the battery that way and also drive electrically off the freeway and on urban or country roads. Then on the bottom left, we have an electric mining vehicle, which is a good application, for example, if we go in underground mines, because we don't have to deal with all the issues from the exhaust emissions. An electric vehicle doesn't create any emissions at all. So it may be a good application for use in underground mines. And of course, there are also some applications in the agricultural sector where you can electrify agricultural machinery. All of these are different technologies, different options that allow to reduce emissions in the heavy vehicle sector. And another project that we were working on is the standardization of signage across Australia, electric vehicle signage. And I've put just a few pictures here on the bottom left part of the presentation, where we see the different signs that are currently in use in Australia, with different symbols on them, no symbols at all, just text, standardization symbols. And this project aims to avoid that in the future. Different agencies, different parts of Australia adopt different approaches to electric vehicle signage. So we are aiming to propose a symbol or propose a sign that can be used all across Australia, that is standardized. So there's the common approach to electric vehicle signage in the country. And that's probably also something that other states should be looking at. If you look internationally, there's still a wide range of involvement of signage around, even in the United States, Europe. That's some of the projects, some of the key projects in that space that we've been working on. I hope to answer some questions, but I want to wrap up this presentation with this COVID-19 overview. It's something that happened about a year ago when the entire world was winding down their the transport and industry applications, running down the economies, and that's where we saw a massive reduction in the carbon emission or the emissions of pollutants in general. And through the electrifications of our transport system, it's hopefully possible to not only have this as the short time, because after that image, of course, it was ramped up again in terms of economic activity, and all the emissions came back. So through the introduction of a clean transport system, we hope to, it's hopefully possible that we achieve something like that in the longer term as well, and contribute to the climate goals that we've set to global warming. That's about it from me.
Awesome, thank you, Robert. I mean,
happy to answer questions.
Yeah, I mean, a lot of information, a lot for us to digest. Really some interesting stuff that you guys have been up to. I think maybe for a South African context, my main question to you is, you've modeled South Africa against kind of Australia. We look over the pond and we see Australia is doing much better than us. What can we do in South Africa to increase our electric vehicle uptake? And all these things that you've spoken about, the making it more, environmentally friendly, low carbon emissions, all these great things that you've spoken about. I think we're all on board with it. We all want to do it. What can you, as an expert in your field, what can you advise South Africa to do to increase electric vehicle uptake?
Well, first we have to know what we have been doing already in terms of electric vehicle policies. But in general, I think it's very important to promote electric vehicles, and to a very good incentive, or initial incentive, to increase the uptake of electricity. If you look at, for example, examples in Europe or Norway even, they have put a lot of purchase incentives on electric vehicles, which made electric vehicles cheaper to buy than petrol vehicles, and that is probably a very good incentive initially to promote the uptake of electric vehicles. But we have to be careful to not overdo it, so that you have to ramp it down at a certain stage as well. Again, there had to be a policy or a plan in place in the long term how this can be done. I'm not on the list. Well, this is one thing that I'm thinking of is a pretty good solution to ramp up electric vehicle uptake. However, other things such as, for example, transport lanes or transit lanes, or privileges for electric vehicles to use certain parking spots, that's probably not so effective in general. It doesn't also contribute much to the emissions goals. For example, if you think about the transit lanes and having electric vehicles use transit lanes, in that case, the electric vehicles, they may be more attractive to buyers because they can drive faster, can get quicker to the destination by using the transit lanes. But all the petrol and diesel vehicles, all the internal combustion engine vehicles, they're still sitting in the traffic and they're still causing emissions because they're idling and being stuck in traffic, which is not a real policy that supports the emission goals as such.
Well, Robert, I think we're gonna have to stop you there. Unfortunately, we've run out a little bit of time. We've got quite a tight schedule for the rest of the afternoon, so I'm gonna have to stop you there. But thank you so much for taking some time. I mean, I know it's late there in Australia. It's 11 o'clock where you are, and I think it's such an in-depth presentation. Giving a lot of information and a lot for us to consider here in South Africa, where we're maybe a little bit further behind Australia. But some great information for us to consider. So from myself, Rob, and Devon here in the studio here in South Africa, thank you for taking some time out of your evening and spending it with us here. We really appreciate it. Thank you, sir.
No problems at all. Thank you very much.
Awesome. Well, I hope you have a great rest of your Tuesday evening. And so that was Robert Kochhan, sharing with us some really interesting stats about the sustainability of low emission and zero emission vehicles. A lot of real big data there for us to digest, to take in. And we probably need to maybe take about a 5 minute break, and then we're going to be back with our closing keynote. Devon,
Yes.
Your good friend, Mr. Frederick John. He's a senior consultant at Neckerman Strategic Advisors, and he's not a question mark, it's a statement saying we need smart cities.
Yes.
And I'm sure that for anyone who hasn't, who wants to tune into one thing today, this is the one that they need to listen to.
This is it. He's an officer and a gentleman, and I'm so looking forward to what he has to say.
Fantastic.
5 minutes time.
5 minutes time. So we're going to take a quick 5 minute break. Get our speaker lined up, get everything sorted out, and in 5 minutes time we'll be back with you at exactly 10 to 3 with our closing plenary for the EMCSA 2021. Thank you very much, and we'll see you all in 5 minutes.